like to welcome everybody to our February South Speaker Series. I'm Fleet Captain Barb Barton. I'm the Director of Sciences, and we have an awesome presentation today that I'm very much looking forward to. Our guest speaker is Douglas Johnston. He's going to be doing a talk on power generation and warp drive. Uh, Douglas is a fellow Star Trek fan since he was just a wee one. He's a manufacturing technician at Oxford Instruments in the UK. Has a background in physics with renewable energy science and a whole bunch more. And Douglas, we are so happy that you're speaking with us today.
Hello, everyone. Thank you so much for having me. Yeah, I think this is only my second sort of official science communication work I've done. First one was the Destination Star Trek Con in Blackpool. I was gonna say this with my presentation, which I'll just bring up now. There we go. Is that shown to everyone now?
Yeah.
Yeah, there we go. Um, there we go. Um, Yeah, I'm going to talk about the sort of Starfleet power generation and warp drive and taking looking from sort of what's real science, what's more fiction based, and sort of the sliding scale, um, which all science fiction is on that scale somewhere. And I think Star Trek is lovely in it. I watched your video from last month with Dr. Alfredo Carpenetti, was it? On the Geordie's visor, that was brilliant.
Yeah, that was
I'm
an
hoping,
amazing talk.
I'm hoping it'll be tolerable compared to that at least. Um, so I'm just going to do a wee introduction of myself. Thank you for introducing me initially, sort of saying my qualifications. That's me on the little destination Star Trek stage. I'm not the moopsie in the foreground. But yeah, at Oxford Instruments, we work on quite high-end research equipment. So we're talking quantum computers and cryostats, some pretty cutting-edge stuff and some less cutting edge, but still sort of not layman's instruments, which has been a very exciting job. But yes, I moved from Scotland to work at that job in England. So I'm originally from between Dundee and Aberdeen, which is not too far away for Scotty from the original series. James Doohan was trying to go for an Aberdonian accent, which I don't personally have, but I really enjoy watching Scotty because he reminds me of some of the people I grew up around. Um, let's get to the talk, if that's all right, if everyone's ready. Um, so it's impossible to sort of talk about power in the Enterprise without talking about the dilithium crystals, um, which, sort of from a chemistry term, I like putting the dash in there. My friend, that's a much more dedicated Star Trek book fan, has read all, well, not all the books, there's a lot of Star Trek books, but he's read a lot of the books. He informed me that it's usually written without the dash in sort of written down Star Trek media, as opposed to with the dash as it would be as a chemical compound. Um, but dilithium as a chemical compound is two lithiums in a gas, which isn't a crystal. A crystal would be far bigger than a diatomic gas. So we can't really make dilithium because it just becomes a lithium crystal as opposed to dilithium, which puts it squarely in fiction, but that's not necessarily a weakness because I've got a picture from Call of Duty Zombies, which some people might be familiar with, some people might not be. Um, but the zombies in Call of Duty are created from this mysterious element 115, which was synthesized in Russia in 2003 and did not create zombies. So that's a bit of a weakness on their sort of fiction end, which Star Trek doing dilithium crystals, which can't possibly be real, have avoided. Because we can't disprove that this dilithium does what they say it does. And what they say it does is that it is porous to antimatter, which means they can store antimatter without needing all the stuff we need to store antimatter. So what I've got over on the right is a picture of one of the things we do make at Oxford Instruments, which I've got the pretty picture of it with all of the workings on show, but in practice it would be in a vacuum chamber and look a bit more like a beer keg, which isn't as impressive. So I got the pretty picture as opposed to the complete picture. But for us to store antimatter in reality, we need extremely cold conditions and high magnetic fields. You really don't want antimatter and matter reacting in an uncontrolled way, as the USS Yamato discovered in the Next Generation when its antimatter storage failed. But in one of the technical manuals for Star Trek, they say they store 300 meters cubed of antimatter for their 5-year mission, which is quite impressive considering in real life we've managed to store just 300 atoms of antihydrogen for 16 minutes. So Star Trek are definitely well ahead of us, but we're getting there. We've managed to store antimatter in freezing conditions in magnetic fields where they haven't annihilated, which a 1 kilogram reaction of antimatter is equivalent to 43 megatons of TNT, or which is roughly half of the sort of destructive energy of the Tsar nuclear bomb, which is the biggest nuke to ever be tested. Um, that's a lot of energy that you can get from antimatter. Um, yes, but we need to sort of look at how warp happens. We know they have loads of power, so they can generate anything they want to. But in regards to warp, we have a lovely image here from a week and a half ago. The Euclidean Space Telescope got this wonderful image of an Einstein ring, which is, you can see I've pinched a wee display of what an Einstein ring is. It's basically, there's a galaxy closer and a galaxy further away, and you usually wouldn't be able to see the further away galaxy. But the amount of gravitational energy the closer galaxy has is warping the light around it. So it is essentially a space-time warp, which is kind of what the Enterprise uses to travel without the sort of effects you'd suffer from traveling close to light speed, time dilation wise. And it's the gravitational energy of an entire galaxy that's doing that, and it's only doing it to light. So that's significant compared to sort of what we can get from a nuclear power plant currently. And trying to measure this in terms of Star Trek, where they use sort of millicochrons and megacochrons, which is a unit of energy that's not real, or using warp nacelles, which we haven't managed to build yet. I think it's fair to say the theory it works. Gene Roddenberry probably didn't know we'd discover actual evidence of the significant space-time warping back when he wrote it into a script in the 60s, but the theory works and we've observed it directly now, which is pretty cool. But we need to sort of think about how we might achieve warp, because we definitely can't use the gravitational energy of an entire galaxy to drag us through space to get closer to the stars. Um, and a friend of mine did give him a bit of a advanced viewing of some of the presentation. He said I should include a nice history of all of the sort of warp in Star Trek from Zefram Cochrane's initial Phoenix warp drive all the way through to the sort of warp 9 in the later series, which is a wonderful idea, but there's a YouTube channel called Certifiably In Game that already has a wonderful series on all of the history of warp and Vulcan warp, and I definitely couldn't come close to that. It's not too based on real science, it's much more based on the sort of what's written down in Star Trek technical manuals and what's said in the show. So I'll leave that to people writing about Star Trek directly, and I'll sort of keep this mostly based on what I can link directly to scientific things we've directly observed or have observed evidence of, like the Einstein ring. I skipped ahead. So if you're on certain parts of the internet, you'll see loads of clickbait articles about how NASA's working on warp drive or Max Planck Institute has discovered warp drive. It's safe to say this sort of should break down really how warp works in the show, which is that you're compressing space-time in front of you to pull you through space and expanding it behind you to sort of propel you forward, a little bit like doing a breaststroke, except you've got the bubble so you're not suffering the time dilation, and that's how Kirk and Spock can go from Earth to Vulcan and back without it being 3,000 years in Earth's future. And there's this brilliant scientist called Alcumbier who studied at the Max Planck Institute and the University of Wales, and I'm not sure where he's working now, but he's always working in theoretical physics, and he wrote a wonderful paper on a workable model for warp drive, which people reported as we've discovered warp drive, which isn't quite the same thing. His paper's got wonderful maths that all work out perfectly theoretically, but he doesn't have a engineering manual on how to build one of these things. It's more in the sort of this is sort of how we might do it in future when we have more technological ability. And it essentially works exactly as it does in the show, but it demands negative energy in order to get the expansion behind you, which is purely theoretical and isn't something we've discovered or been able to harness in any way. So his maths is great, his theory is great, but we don't have that ability, sadly. But we might in the future, which will be pretty cool. And some of you might have come across this working warp field um, that an ex-NASA employee built in his garage. Um, the guy himself is quite convinced he's gonna bring us to the stars. According to him, his warp drive can move approximately the weight of a half pint of milk a couple of inches. And it hasn't ever worked in front of a camera or people watching it. So it makes for great clickbait articles, but I don't think this warp nacelle is taking us to the stars. This little one on the left. I think it's safe to say we're not quite there yet with what we're currently able to do, but we've made wonderful progress, definitely. Um, so I seem to have raced quite fast through. Yeah, I did take some stuff out because when I was presenting it to my friend yesterday, I ran long and now I've run short by talking too fast. Um, yes, uh, so we may not have wonderful things like dilithium crystals or negative energy or exotic mass, and we may currently be stuck within our solar system. But that's why I ran short. Sorry, I'll take us back a little bit. I do apologize. In regards to the sort of antimatter matter interactions, um, so there was uh, an antimatter burst seen at a distant, not a star, but a observable object called GRB 221009A, which is 274 light years away from Earth, or over a million times further away from us and the sun. Um, so, keeping in mind that the disaster at Chernobyl was massive for us, that was felt halfway across the world. That wouldn't even really be detectable from Mars, our sort of closest neighbor. And we were able to detect the gamma ray burst from this antimatter matter interaction from 274 light years away. And one peak of this antimatter burst, so it went on for longer than this. This was just one peak observed, was 2.1 times 10 to the 47 watts of energy, which is enough to power America's current energy demand for 6 billion years. And that's not 3 billion, that is billion, so times 10 to the 27 years, which is a quick back of the envelope calculation, not taking into account that we wouldn't be able to harness that energy without being vaporized. And America's power demand will go up over the years, but that amount of energy is not something you want going off accidentally. So it would be wonderful to get some dilithium before we try and store that much antimatter. You you really don't want that going off anywhere near people living. And you certainly wouldn't want to be on the Enterprise looking at an uncontrolled antimatter matter burst from what doesn't look like very far away. Um, yes, so with a lot has happened since the 1960s that was written into the script that was purely theoretical at the time that we've now observed. So we've now been able to store small amounts of dark matter. We've been able to see how dark matter interacts with real matter, and it's not too far away from what they say in Star Trek. One thing they do get wrong is they say they change the mixes of antimatter and matter, but it's always a one-to-one reaction when it annihilates. So changing the amount of antimatter and the amount of matter you have won't change the amount of power you have for your warp drive. That's one thing they got a little bit wrong, but they got a lot right, which is pretty impressive. And we've been able to observe things like Einstein rings directly, which sort of prove that warp is a feasible concept, even if it's not currently achievable. We've got wonderful theoretical models like the Alcubierre drive. And if you want to believe the guy that built a warp drive in his shed, we have a working warp drive. I have definitely left a lot of time for questions. I do apologize for that. I've absolutely raced through this. I will say, if you like the backgrounds I've used, most of these are from the Gaia Space Map, which is available to watch, available to look at online for free. It's basically a giant map of the stars at night, and I think it's really lovely. Basically, the entire sky by the time they finished. I don't think they've finished yet. I've just got yeah, I've just got the one slide left. So if you're looking for more sort of science related to science fiction, you're in exactly the right place. The Soul Speaker series is absolutely great for that. Um, One of my favorite people to sort of watch is Jamie Gallagher, who actually organized the speaker series for the Destination Star Trek in Blackpool. He's a wonderful professional science communicator. That's actually his day job, is that and helping scientists communicate for their sort of theses and stuff. I've not got much up online yet, but I am planning to do some sort of Star Trek Doctor Who YouTube videos. So if you've got any ideas of what you'd like to see or hear more about, you can contact me directly. I've got my science communication Gmail, I've got my LinkedIn. This wee QR code will take you to a page that has direct links to that if you don't want to type stuff in. I've added some key resources. It's academically, we're always told to keep the bibliography, and it is awfully helpful going through the presentation, knowing where to go back for things. I will recommend for anyone with an interest in it the Physics of Star Trek book that I've listed there. It's very thoroughly researched. I took a fair amount of information from this for my talk at Destination and for tonight. Or I think it's afternoon for a lot of you, as opposed to night. And then the paper about the gamma ray burst 274 odd light years away was in this science paper, which I have to get delivered from America because they don't sell it in the UK, which is a bit annoying because there's a lot of wonderful astronomy going on in the US that we don't. We have ESA in the UK, the European Space Agency, but you've obviously got the James Webb Telescope, the Chandra X-ray Telescope. You've got wonderful space telescopes in America that we don't have as much access to in the UK. And sadly, the funding is getting cut a bit for the Chandra and the James Webb, and the Chandra might get cancelled early, which is a bit sad, but hopefully that gets sorted. Hopefully they can keep it running because there's nothing actually wrong with the X-ray space telescope. It's just not, it's not, it doesn't make as pretty pictures, so it doesn't make as many headlines, and the funding's just gotten put down a bit for it, which is a bit sad. But yes, I do apologize for absolutely racing through that. I hope I wasn't talking too fast for people to understand me.
No,
Um,
it was very informative, and I'm sure knowing the people that are on this presentation that you're probably going to have quite a few questions. So I'm going to turn off the spotlight,
yeah, I'll take
and
the
um, we can go back into our little gallery view, and folks can uh,
that on there.
ask questions if they have them. And could you, whoops, I got to get back to the Zoom again. Um,
Do we raise our hand or something?
Turn off the share. Yeah, I've got to get the Zoom screen back up here.
I'm
Oh,
gonna take the.
no.
Am I able to take the share off? Um, I'm not sure.
All right. Participants, here we
Oh,
go.
there we go.
All right. Now I'll go back to gallery view to see everybody. There we go. Always a technical, always a technical issue. So yeah, anybody wants to ask a question, feel free to raise your hand. Eric?
Yeah, I'm gonna start with one. So you're talking about that gamma ray burst. It was 200 and some odd light years away from Earth.
Yeah,
What was the all right, so GRB obviously.
yeah.
What's the oh, oh, malarkey? Um, I just got my phone ringing. It's like, nope, I don't want to talk to a robot. Um, yeah,
Yeah.
just hang on a second. I'm just gonna tell it to shut up. There
Oh,
we go.
I think Eric's question was going to be what was the designation of the gamma ray burst?
Correct.
yes. It was. I've just opened the chat and seen I've missed a few questions in there. So it was the 221009A,
Okay.
which someone's
Hmm.
helpfully typed in. And yeah, that was
9A.
the
Because it's
paper in the magazine. Well, the
uh,
publication.
weird because it says it's 2.4 billion light years away.
For sec.
221009A. If that's right, then it's I'm thinking I might have the wrong designation.
2100. For 207. I have. Yeah, no, that's my mistake. It is 224. Yes, it is much further away than I'd had written down, which means it's probably an even more catastrophic
Oh yeah.
explosion. That's significantly further away. Um, so you definitely wouldn't have wanted to be on the Enterprise D as that was going off right
You
next
wouldn't
to you.
even want it in the same galaxy as us.
No.
Let's see what else. So when we're talking about power generation and the warp drive, is the warp drive a electrical thing? Is it run by electricity, or is it something else?
A big thing is the warp is a gravitational effect, which we can't do with electricity, but the big thing with Star Trek is they have artificial gravity on board their starships.
Yeah.
So they definitely have the power to induce gravity through electricity somehow. We haven't worked that out yet.
I was thinking about they've got the matter. You got the diagrams, and they've got the matter coming in the one end, the antimatter
Yeah.
coming out the other, and something coming out that's a tuned plasma. Really? All right, so
Yeah,
plasma is an excited form of matter. Fine. So if you've got 1-to-1, you should just have energy coming out, not a plasma. That just confused me, but whatever.
yeah, I think because they talk in Next Generation certainly about their deuterium mixture going into it, which I think that's essentially heavy water, which we use in nuclear fission reactions and probably will use in nuclear fusion reactions. So I think it might be a case of boiling water and using the energy from that as electrical energy. It might be.
So, a nuclear power plant, for example, is like there's the uranium, and then you have three transformations that go on in there.
Yeah.
The first thing that happens is the uranium decays, produces heat, and then that's first transformation, and then the heat is essentially turned into kinetic energy when you boil the water and you've got the high pressure, and then that's the second transformation. And the third transformation is when you take this kinetic energy and turn it into, you spin up a transformer and make electricity from that. So there's three transformations in there. And I'm just wondering how many would actually go on board the ship, whether it's another version of the tea kettle, where
From
they're using, boiling water and then using that too.
yeah, from the sort of the manuals and stuff that you see in the diagrams, it does look like it's essentially the sort of the explosive energy is boiling the water and then that's getting converted. But personally, I'd probably do it a bit more like a car engine where the explosive energy is doing pistons, because nuclear fission and fusion, it just gets hot and boils the water, but antimatter and matter is explosive energy, like the petrol in a car engine, but much bigger. So I think if we were to do it, a car engine sort of model might not be the worst idea, but that's not how the manuals look. So
No. One of the other weird things I saw is when they're transferring power around the ship, they've got these plasma conduits. All right. It's like, all right, so I was puzzling about that for a while. I'm thinking, okay, so are they instead of having a physical conduit for the electricity, do they have this plasma, which is then they can run the electricity directly through the plasma?
that
Is that
is one I've always been a bit curious about as well. It's a bit like the fluid links in the TARDIS and Doctor Who. It's sort of it's sometimes used as a plot device, but we're never explicitly told what it's used for. But I would like to know as well.
so I think it's probably the introduction of a new element that I call hand wavium.
Yes.
There's a lot of that, or the unobtainium, which is another one, another fictional element.
Yeah. No, I would certainly like to find out more about the plasma conduits because that's a very good question, what they do. Um,
So I have a question, if you don't mind. I'm keeping my camera off because I'm in my hoodie. It's freezing in this room. Um, so actually, I have two questions. I think our best bet for generating enough energy for fusion for warp drive in real life is fusion. There are a number of promising sort of companies that are doing that. One in the UK who have actually achieved an actual fusion reaction and sustained it. So my question is that in Star Trek they very often say, "Oh, we need to make sure the magnetic confinement is correct," and in the reading that I've been doing, that's the very problem we're working on today to try and get a fusion reactor up and running. And of course, we've got two competing technologies. We've got a tokamak and we've got a stellarator. So I was wondering what you put your faith in, or if you put them in both.
yeah, that's so fusion is obviously the most promising we have today. And it does sort of depend on the magnetic confinement because you don't want a fusion reaction getting out of control either. A bit like if you've seen the Tobey Maguire Spider-Man 2 film,
Yeah.
where he gets the fusion reactor going and can't stop it. We definitely don't want that.
No.
And in regards to which ones to put my faith in, I like any of them that people are actively working on and able to get funding with. Because the more people working on it, the more likely we'll get a really good one.
Yeah.
It's sort of, you don't want one person getting a monopoly and then if they make a mistake, the whole field's dead. So,
Very, very true. Very true.
yeah.
And then my second question is, it's a very tenuous link, but it might be within your field of study. So currently they're experimenting with AI to be able to confine that plasma more efficiently, certainly in the stellarator design, because they have to make the magnets in some weird shapes and stuff. But a couple of days ago, Microsoft announced that they had created a topological qubit, which is the beginnings of a quantum computer. Do you think quantum computing might eventually solve this energy problem for us?
With a bit of luck, yes. So I do sort of work with quantum computers at my work, but I'm more in the assembly side of it. But I do come across bits of writing and stuff to do with them, which I find very interesting. And they can work on sort of multiple answers to a problem at the same time, which is, I guess, similar to the answer I just gave you to the other question. It's faster when multiple things are working at the same answer because then whoever gets there first gets an answer faster. Whereas if one person or a traditional computer would have to work, get it wrong, work, get it wrong, work, get it wrong, a quantum computer can work on, say, 10, 20, 100 things at once, and two or three of them might be right. So
Excellent. Thank you.
that's
I
the sort
guess
of the benefit of quantum over traditional computing.
absolutely. Just one more observation. Alcubierre said that, creating this warp drive and going at warp is great and everything, but stopping is an issue.
Yeah, that's definitely something we struggle with a lot because I work with cryogens a lot because we work with things down at sort of 3 or 4 Kelvin, which is um, like I've had to write it down because we don't tend to use it. Roughly about minus 453 Fahrenheit. Um, and the problem with when you get stuff that cold and you're trying to get specific temperatures, stability can be an issue. You can overshoot very easily, which if we struggle with that with a sort of cryogen computer system, I don't know how we would fare with our current computer abilities, making sure we get the right stopping point with a warp drive equivalent. I think you're absolutely right. That's something we should be very worried about.
Absolutely. Thank you. Thank you very much.
Thank you. They're very good questions.
So do we have any more questions today for Douglas?
I just realized that the last talk we had, we also talked about the that gamma ray burst. They called it the boat, biggest of all. I can't remember what
Yeah.
the T stands for, but yes, we talked about that as well. The boat gamma ray burst.
Thank you for mentioning that because I couldn't remember the name, the acronym. I didn't go back and look at my notes. I'm going to write that down. Oat. I remember that.
Brightest of all time. Sorry, brightest of all
Brightest,
time.
yeah.
That's on the link for the GRB 2210009A that I put in the chat thing.
You remember that? You can remember that number? Oh my God.
Now I've got it on. I've got 2 screens, so I can just.
Okay. Okay. I'm not impressed. I'm not impressed anymore. Any other questions?
If that's all right, Eric. I would like to know what technological advancement are you most looking forward to us getting from Star Trek? And what technological advancement from Star Trek do you think we are closest to getting or most likely to get?
That's a very good question. I think the coolest one for us to get would be warp drive, because then we could go and discover things outside of our solar system. But I definitely don't think that's what we're most likely to get. Possibly what we're closest to, which is very exciting, would be don't know if this is a cheating answer though. You'll have to let me know. Looking back to Zephyr Cochrane's early warp drive ship, the Phoenix, I think it's called. It does use a fusion reactor in it, and I think that's what we're potentially closest to and what would be coolest for us to get. But is it kind of cheating to use a Star Trek historical thing to answer that?
They sort of changed the history a little bit. It didn't used to be the Phoenix.
No.
If you go back in the day, it was actually we actually had to get to Alpha Centauri the slow way, and a scientist there named Zephyr Cochrane
Mm-hmm.
was the one who came up. They brought him back to Earth, and they worked on it here, and that's how they got the first warp drive. So I get one other for you. As the next step. Oh, here I'll just hit the enter key here. Well, come on, is it going to work? Yes, there it goes. And I mean like on an industrial scale. Carbon nanotubes. You know what I'm talking about.
Yeah. That is a very good question, because when I was sort of younger in high school, carbon nanotubes were going to be this new thing that we're going to solve all of our material issues, and they have sort of vanished out of the news a wee bit, which is awfully disappointing. would be wonderful if we came up with an effective production.
I'm thinking the next step would be a space elevator, being a cheaper way and less explosive way of
Yeah,
getting stuff into orbit. And that would be the
absolutely.
next stage, is being able to freely get to and from orbit without having to
Yeah.
worry about, oh, your cargo got blown up with the rocket.
Yeah, because that is the main difficulty, the getting out of the atmosphere. So if you're able to take payloads up without worrying about that, that would save a lot of hassle for everyone doing anything in space. And I do remember the papers and news stories about the carbon nanotubes will be effective on a space elevator, which would be great if we were able to manufacture them on that scale. And if we could have governments all sort of in agreement of where the space elevator would go and who's paying for it,
Yeah.
which might be a bit of a struggle.
Politics rears its ugly head again.
Yeah. Although we've not had eugenics wars yet, so we're doing well.
Or World War III. So I'm thinking we're already in an alternate timeline.
Yeah.
I don't know if that's a good thing or a bad thing.
Reading through some of the questions, I do apologize. I might have said dark matter storage instead of antimatter storage. That wasn't a slip of the tongue, a mistake. Yeah. What is the book? Book. I can type in the book title. If that person asking about the book I brought up or a different one. I don't know. If they're asking about this book, I'll put that in the chat.
While he's doing that, I can mention we had a speaker back in July, Matthew Sedegas from the University of Albany, SUNY, who did a talk on models for how space-time travel could work. So if you want to check out that video also, that's on Starfleet's YouTube channel, and explore the topic even further. It was pretty mind-blowing.
Which what was the title of that one again? That sounds rather good.
That was called The Models for How Space-Time Travel Could Work. Dr. Matthew Sedegas. And that's the July 18th, 2024 Sol presentation.
Yeah. So is he talking about the sort of the Frank Tipler books and stuff like that?
I don't remember exactly what books he talked about, but they were talking about research, and I'm not a physicist, I'm a biologist, so stuff is mostly over my head, and I grab at it, but I just never can catch it. So, but it was pretty interesting. He offered a class that was 6 weeks long, 3 hours lecture that were recorded on the subject, and I thought I'd try that, but yeah, it didn't help. Anybody else
I
have
would
any
say,
questions? Oh,
I
sorry.
was going to say, I would second the recommendation of the Physics of Star Trek book. I've got it, and it's very good.
Very good, yeah. I got another one called The Science of Star Trek by someone else, and I wasn't quite as impressed with that one, so I always recommend this one.
Yeah.
All right, well, if we have no more questions, I want to thank you so very much. Oh, we do have another question. Go ahead. We got time. Your microphone's muted, or can you unmute?
Yes, I was.
Whoops, sorry. Still muted.
No, I was just posting to say I'm leaving, but thank you very much, Douglas. That was
Thank
fab.
you.
So I'm going
Thanks
to
so much for joining.
my chapter. It was great. Thank you, guys.
Have a good day.
Yes. I wanted to just make a quick announcement for our next speaking event. We're changing things up. We're trying to find that magic sweet spot where the most people around the globe can watch. We had it every third Thursday at 7 p.m. Eastern Standard Time last year. And thanks to Pam for reaching out and telling me I was being Americanist and ignoring all the people across the pond, which I didn't even think of. So thank you for that, Pam. I'll keep thanking you for that. So our next speaking event is going to be March 8th, Saturday. Anyway, it's going to be at 11 a.m. Eastern Standard Time. And our speaker is going to be Sarah Treadwell, who's a NASA space ambassador. And she's going to be talking about something I think I will be able to understand, and that is astrobiology. So I think that's going to be an interesting topic. And hopefully that time will work on a Saturday for more people to join us live so they can ask questions and not just have to go watch the YouTube. But was anyone able to confirm or deny?
It is going to be March the 8th at 11 a.m. Eastern Time and 4 p.m. GMT.
And with that, I want to thank everybody for joining us today. And again, Douglas, thank you so much for sharing about warp drive. We have a lot of people interested in physics in our group, and I'm glad they were able to ask questions because I wouldn't even know where to start.
Yeah. Thank you so much for hosting me, and thank you everyone for joining and the wonderful questions, because obviously anything I didn't go into today, when I do get around to posting stuff on YouTube, I can very much use these questions to format videos people are curious about. So thank you so much.
Yeah, and thanks for all your work going out and educating people. We need a lot of science education right now, so hats off to you for that good work. All right, everybody, we'll see you next time, March 8th. Write it on your calendar. Live long and prosper.
Live long and prosper.